Okay. Which questions on this shark bite do we want to see? Do go over, have questions about. You can show me on your hands. Is that 4 and 1? Okay. You guys have opinions? Are you showing 5?
3.
You can just show it on your hands. Jessica, did you have questions you wanted to see? Do go over, show me on your hands. 3. So I had 2 for 3 and 2 for 4. Any others? Everyone choose between 1 and 2 because I saw those. You guys choose between 1 and 2. 1, 2, choose on your fingers, on your hands. Alright, that looks like 2. Alright, for number 2, we're going to simplify this, just combining like terms. So these two have k's. So I would do exactly what it says. Negative 15 plus 2 would be negative 13k. And then combine my constants, the numbers, negative 1 plus 12. So negative 13k plus 11 will be that final answer. Make sure you're writing your work and answer on your shark bite answer sheet. Do we have questions on that one? Negative 15 plus 6. And then negative 1 plus 12. Number 3, write the equation in slope-intercept form. So we have to solve this, get rid of x first by subtracting. Then we can rearrange this, put this as negative x minus 8. And then divide everything by negative 1. There's an invisible 1 right here, so divide everything by negative 1. So that we get y equals x plus 8. Questions on that one? Okay. And then with number 4, we're just combining like terms. So similar to number 2, distribute the negative 3. This is a negative 1 that we're distributing, and the 5. So we would have negative 12x minus 6 minus 2x plus 6 plus 15x minus 20. And then just like we did in number 2, combine all of the like terms. So the ones that look the same. All the x's. So negative 12 minus 2 is negative 14. And that combined negative 14 plus 15 is just x, or 1x, either or. Negative 6 plus 6, well that gives me 0, minus 20. And then 0 minus 20 would be a negative 20. So x minus 20 or 1x minus 20 would be that final answer. Questions on that one? I'm not going to give you the answer to that one because we already did 3, but you can ask anyone else for that one. Okay, so make sure you are holding on to those and putting them on your shark bite answer sheet. The next one, you'll be turning in that shark bite answer sheet. Everyone look at your course calendar. So notice that this is a shorter unit there are only really two objectives, what we're going to talk about today, and then what we're going to talk about over the next 2 classes. And then we're going to be quizzing and testing. So there are only 2 delta maps. The one that's listed for next class and the one that's listed for the class after that, those are just the same one, it's just repeated. They are both going to be formative because there's only 2 of them. Also notice that our flex day is shortly right before the quarter ends, so that will be a chance to last minute get your grade up. Also, everything on this unit, so everything from unit 2B, will be on marking period 2. So the last grades in marking period 1 are going to be the shark bite answer sheet and the cumulative review, which I got from most of you already. Questions on any of that? And we only have a few weeks before the quarter ends, so if you need to get your grade up, you have to do that as soon as possible. Okay, so we should remember a little bit about parallel and perpendicular lines from geometry, but we're going to talk more about the algebraic side of it rather than the graphic side of it. What do we know about parallel lines, if we remember anything? Something about them is the same. Say that again. I can't hear you. What about it? Okay. So, in general, parallel lines are 2 lines that never cross or never intersect. So 2 lines that never intersect. But algebraically, we know 2 lines are parallel if they have the same slope. Do you remember anything about perpendicular lines? They do cross, yes. And more like they make a T rather than an X. It's 2 lines that cross at a 90-degree angle. Or that intersect. So 2 lines that intersect at a 90-degree angle. They make that perfect T. Your X and Y axes are perpendicular lines. Algebraically, we know 2 lines are perpendicular if they have negative reciprocal slopes. We'll talk about what that means here in just a second. So we've heard the word reciprocal before. When we're solving, we multiply by the reciprocal, the flipped version of a fraction. But a negative reciprocal is not just flipping the fraction, but also making sure one is positive and the other is negative. So this is a flipped fraction. Where the signs are switched. Or you can say the signs are opposite. So we're going to look at these numbers and decide what the negative reciprocals of these numbers are. So do you make sure you're writing this down? So in number 1, if I took 3/4 and I flipped it and I made it negative, what would that number be? Negative 4/3. What about 2? 2 is really over 1.
So
Negative 1/2 or negative 1/2. The negative reciprocal of negative 7/8.
positive 8/7.
Positive 8/7. 1. Negative 1. Because I would take that, flip it, make it negative. It's already over 1. And if I put that over 1, that would just simplify to negative 1. Now this next one is kind of tricky. So if I have 0 over 1, that's still 0. But if I flip that and make it negative, what is negative 1 over 0? No.
See if it's 0.
It's not 0 either. It's a type of slope that we talked about. Undefined. So when you see a 0 and an undefined, those are negative reciprocals, even though they don't look like the others. We just have to keep that in mind. Questions on that part so far? Okay. So then we're going to determine if these are parallel, perpendicular, or neither by finding the slope by using our slope formula, y2 minus y1 over x2 minus x1. Okay, so we're going to do that for both of these. Label these if you need to, x1, y1, x2, y2. We're going to go ahead and find the slope for AB first by doing 6 minus 3 over 2 minus a negative 2. Just go ahead and close your mouth. You can grab your calculator though. What would that slope be? It is 3 over 4. So then we're going to do the same thing for CD. 3 minus 0 over 3 minus a negative 1. What would that slope be?
3 over 2.
Not 2. It's 3 over 4, because that would be a plus. Because the 3 minus a negative 1, then minus and negative would come together and make a plus. So if I have the same thing, 3/4 and 3/4, those are going to be parallel lines, because they have the same slope. So you can write out the word parallel, or this is your symbol from geometry, parallel lines. Questions on that before we do another one? Okay, let's try number 2. Let's go ahead and find the slope of AB. Do the same thing. 4 minus 2 over 5 minus 0. What would that slope be? 2/5. So make sure you're doing this over this. And then do the same thing for CD. So 3 minus 8 over 3 minus 1. Negative 5 over. It would be positive 2. 3 minus 1 would be a positive, but this would be a negative. So if I'm looking at those two slopes, 2/5 and negative 5/2, would that be parallel, perpendicular, or neither? Perpendicular because it has a negative reciprocals. They are flipped versions of each other, and one is negative. So you can write out perpendicular or do an upside down T. Questions on that one? I'm going to show you a neither case. So let's do the same thing in number 3. We have 6 minus 8 over 2 minus a negative 1. What would that slope be? Negative 2/3. And then the last one, CD. That would be 3 minus 2 over 3 minus a negative 1. What would that slope be? 1/4. Are those parallel, perpendicular, or neither? Neither. Because they're not the same, they're not reciprocals. It's clearly a neither. They have nothing to do with each other. I'm going to show you some other neither cases. So if they obviously don't look the same or anything related, neither. They could be almost parallel, but maybe one is negative. Those would not be parallel, they would be neither because they almost are the same, but they're not because one is negative. Or they could be like your perpendicular, and maybe they're reciprocals, but they're not negative reciprocals. One isn't negative, so this would also be neither. Or if they were both negative, this would also be neither. So be on the lookout for all of those types of examples. Okay, we're going to do one more of these before we jump into the equations part. So look at number 5. I'll rewrite our slope formula here so we're not flipping back and forth. Okay, let's find the slope of AB. Over 0. We'll come back to that. And then for CD, what would that slope be? 0/3. Now, as is, would we say these are parallel, perpendicular, or neither? Neither, because they don't look anything alike, right? But if we simplify them, what is 9/0? It's not 0, it's not 9. It's undefined. Anything over 0 is undefined. And then what about 0/3? It's not undefined. It would just be 0. And 0 and undefined are parallel, perpendicular, or neither. Perpendicular. Yes. Because that's going to be the case that trips you up every single time. So remember that those are perpendicular. Okay, so if you get something like this, keep going. Remember that this is undefined and this is 0. so that those would be perpendicular. Okay. Any questions on how to determine those from finding slope? We're going to look at equations now. In number 9, yes. Say that one more time. Okay, in number 9, are those parallel, perpendicular, or neither? Looking at the slopes. Are they the same? Are they negative reciprocals? Are they not related at all? They're the same, which means they're parallel or perpendicular. Parallel. Because they have the exact same slope. Also, with parallel lines, we need different y-intercepts. So these are parallel because they have the same slope and different y-intercepts. What about number 10? Perpendicular. Because they're negative reciprocals. They're flipped versions of each other, and one is negative. What about 11? They're not parallel, they're not perpendicular, they are neither, neither. Because they look the same, but one is negative, so that can't be parallel. They are, one is negative, one is positive, but they're not flipped. Okay, so then we're going to do one like 12 and do one more of these, and then jump to the next thing. And that'll be the last thing. Okay, so in 12, we couldn't determine that right away because we have to solve both of these. So in this, we have to get x by itself, kind of like the one on the short right, by subtracting x. And then to get y by itself, what would be the next step? Divide everything by 6. So y equals, I can write this as negative 1 over 6x plus 5. How would I get the second equation by itself? Or y by itself in the second one? Divide by 3, yes. Divide everything by 3. So we have y equals 6x minus 2, not 3. So they're what? They're perpendicular because they are negative reciprocals, because this is really over 1. Do you have any questions about that? Last one on this page. Number 16. This is a y equals and an x equals, so we're going to go back and remember our Hoyle-Bucks. Horizontal lines have 0 slope in our y equals. Vertical lines have undefined slope in our x equals. So the y equals has what type of slope? I did just say that. It's a horizontal type of line. But what's the slope? 0. And an x equals has what type of slope? Undefined. So if I have a 0 and undefined, those are parallel, perpendicular, or neither?
Wait, perpendicular.
Perpendicular. Every single time, 0 and undefined are perpendicular. Okay, I'm going to draw a visual so you see what this looks like. You can draw this if you want. You don't need to. draw in that horizontal and vertical line. They cross and make that T, so I can see that those are perpendicular. Everyone take 10 seconds. Stand up and stretch. Just wiggle out your feet, toes, all of that for 10 seconds. It's fine. Fall asleep. I gave you the opportunity. Cool. We're going to do 4 more problems and then you're going to practice. We're going to do this page and then you guys are going to practice. Okay. All right, ready? Go to this page. And there are 2 parts to the parallel and perpendicular stuff. So we did part of it. Being able to determine are things parallel, perpendicular, or neither from different things, as well as being able to write an equation. So we have to keep in mind that parallel lines have the same slope and perpendicular lines have negative reciprocal slopes. So in these examples, we're going to be given some equation and a point. And we have to find another equation that is parallel or perpendicular to the original. So this will be very similar to when we were writing equations and we had a slope and a point. Similar but different. So we're going to use a mixture of our point slope and our slope intercept form. So I'll rewrite our point slope. Just like the writing test, you'll need to be able to do this. So in this first example, before we do anything else, we're going to cross out this y-intercept. We don't need it. It will only confuse us later. So we're just going to get rid of it. We can do this because we don't ever use it. Okay. Then, because we're writing an equation that is parallel to this one, the slopes are going to be the same. So I'm going to just write that my slope is going to be -4 for my new equation. Then I have my slope and I have my x1 and y1, and I'm going to use my point slope formula to put all of those in and solve it. We have y minus 7 equals our slope -4 times x minus a -2. The minus minus will become a plus. Do that before you distribute. Then you could distribute the -4. So that we have y minus 7 equals -4x minus 8. And last step, add 7 to both sides. What would that final equation give us? -4x was the last part. I just couldn't hear you. So if I look at this and I compare it to the original, these have the same slopes and different y-intercepts. And I'll show you how to check yourself on Desmos here in a bit. But that would be, it would go through that point. Okay, questions on that before we try the next example? So the next example is going to be similar, but we have to solve this equation put it back in slope-intercept form first. I'm going to do that over here. So we're going to get y by itself by subtracting x. Rearranging this so that it's negative x plus 9. And then dividing everything by negative 3. So that y equals, this would become a positive 1/3 x minus 3. Now that is not the answer to our problem. It's just a way to find our slope to solve our problem. So I can get rid of that negative 3, I don't need it. Our line is going to be parallel, so I know the slope is going to be the same, 1/3. Now in this case, I will use slope-intercept form just to show you how that would work. Where I'm going to put negative 1 in for y, 1/3 in for m, 3 in for x, and then I don't know my b, so plus b. Then we can multiply 1/3 and 3 and get rid of 1. So that once we get that y-intercept, we can rewrite our equation. Y equals 1/3 x minus 2. And this would be parallel to the original with a different y-intercept. Do we have any questions, confusions on that so far? So both of the examples we just did were for parallel. So now we're going to do the exact same thing but with perpendicular. So in number 3, this is in slope-intercept form. I'm going to cross out that y-intercept again because we don't need it. But before I start the work, I have to change the slope so that it's the negative reciprocal version of this. What number would that be? It would be negative. I didn't hear the rest. It would be negative 1 over 2, yes. So you have to do that first. If you don't change this first, the rest of your work and answer is going to be wrong. Okay, we'll use point slope for this one. We have our m, we have our x1 and our y1. So that this would be y minus 3 equals negative 1/2 times x minus 4. Distribute the negative 1/2. And add 3 on both sides. That y equals negative 1/2 x plus 5. Questions on that one before we do the last one? So the last one is like example 2, but it's perpendicular, so we have to change the slope. So let's solve this first. Get y by itself by getting rid of x. Divide everything by 3. So that doesn't answer our problem, but now I can find the slope that's perpendicular to this, which would be what? Positive 3 over 5. So I'm not going to use that y-intercept. I'm really not using that slope either because I have to change it. And then we're going to use our slope-intercept form for this. So 1 equals 3/5 times negative 5 plus b. Multiply 3/5 and negative 5. The 5s would cancel, the negative would stay the same or stay there, so would the 3. And we could add 3 on both sides. So that our equation would be y equals 3/5 x plus 4. Now, while you're practicing the delta math, you could be doing this on Desmos. Now, make sure you still know how to do this, but I'll show you how you can practice this in Desmos. So if you want to try this as I'm doing it, you can do that. I'm going to use the last example. So first, I'm going to put in the equation that we were given, 5x plus 3y equals negative 21. Then I'm going to make sure the equation that we solved was the right one by putting that in. They should overlap. So that was negative 5/3 x minus 7. So that happened really quickly, but they should overlap. Then I'm going to put in the point that was given, so negative 5, 1. And I'm going to type in y equals mx plus b. And you'll get this that pops up. You can choose all. We know our perpendicular slope should be 3/5. So if I type in or change that to 3 over 5, and then I move this either by hitting play or just manually moving it until it goes through that point, this will tell me that my line, the equation we got, was right. The y equals 3/5 x plus 4. So if you need me to do that again with you individually, I can do that. So you guys have a delta math that's due tomorrow. That's the parallel perpendicular lines. That is an assignment still. I don't remember if I asked you or not, and then I went ahead and changed it anyway, so we'll just move on with that. After this assignment, all of the rest of the delta math assignments will be in the delta math. So this one will still be in assignments, but moving forward, they'll all be in the delta math. You guys can move around, work on this, get help if you have questions.